Hello students, in this video I'm going to show you some real quick easy ways to figure out the math involved with dilutions. So let's start here with some basic vocabulary that you need to know. There's a simple dilution, which would be like if I diluted some coffee. So let's say I had some concentrated coffee and I'm going to add water. It says 9 cups here, it's a little hard to see. So I'm going to add 9 cups of water. This is a 1 out of 10 dilution. Remember, the bottom number is always going to be your total volume. That's very important, and it's a common mistake that beginners make when they're first starting out with dilutions. So the bottom number of your fraction is the total volume. Now, the original stuff that you start with is called a concentrate. If it's in liquid form, it's typically called a concentrate. If it's a solid being dissolved in a liquid, we would call that the solute. The stuff that we're dissolving with, in this case water, is the solvent. It's the stuff doing the dissolving. Sometimes it's called a diluent, which is the stuff we're using to dissolve, is the diluent. The serial dilution is what you see down here, and that's where we start with a concentrate and then we gradually dilute it one step at a time, and that's what makes it a serial dilution. Notice the amounts are the same each time, and that's pretty typical. These little amounts that you move are called aliquots. So an aliquot is a portion that represents the whole. We take a little portion out and move it to the next container. And as we go from step to step, we gradually dilute our original concentration. All right, let's take a look at the math, because that's what everybody's worried about. Let's say I want to make a simple dilution. I'm going to dilute my simple green cleaner here, and we're going to use 2 ounces of the concentrate, and I'm going to add enough water to make a total volume of 32 ounces. Okay, typically what we're going to do here is reduce the fraction. So I can do that in my head. So that's a 1:16 dilution. Sometimes it's written like this. Okay, now what if you can't do it in your head? What if it's some goofy number like 6.5 ounces of concentrate to make 32 ounces of solution? What do? Okay, now I could go through all the algebra steps to show you how this works, but the purpose of this video is to give you quick and easy ways of figuring these out. So all you're going to do is you're going to take the bottom number, 32, divide it by the top number, put that in your calculator, and you're going to get 4.923, yada, yada, yada. It keeps going, okay? Now, you're going to need to round this off. If you've already taken your chemistry course, you know significant figures. If you've forgotten the rules, basically you count the digits in the original problem, and that's how many digits you want in your answer. So 32 has 2 digits, 6.5 has 2 digits, so I want my final answer to have 2 digits, so that's going to be 4.9. So this is going to be a 1 to 4.9 dilution. Okay, so that's all you have to do. Bottom number divided by top number, round off, make it a ratio to 1. There you have it. Now, what about serial dilutions? Let's start with the most common and basic serial dilution, which is called a twofold. And basically what twofold means is we're cutting the concentration in half with each step. So let's take a look at this example and see how that works. I'm going to make a basic serial dilution across 6 test tubes. Tube 1 has 10 milliliters, so let's mark that, 10 milliliters. Tubes 2 through 6 have 5 milliliters of water each. So 5 milliliters of water is going to be our diluent. That's our solvent. 5, 5, 5. I know it seems silly to some of you to draw this out, but trust me, if you're a beginner, drawing it out really, really helps. Now it says I'm going to transfer 5 milliliters of liquid serially, starting at tube 1. So that's going to be my aliquot. I've got 5 milliliter aliquots each time. And again, if you could draw this in if you want, you don't have to. Now, what's my total volume going to be in tube 2? Well, I started out with 5. I'm adding 5. So that means my total volume is 10. And notice that's going to happen every single time. My total volume is going to be 10. Okay? Now, what's the top number represent? The top number represents how much of this original concentrate ended up in that tube. Okay? So in tube 2, it's 5 out of 10. Now I can reduce that. That's going to be a 1 to 2, or 1/2. Now, what is that as a decimal? It's 0.5, right? That's going to be my multiplier. I'm going to bring that up here, and I'm going to multiply 5 times 0.5. What's half of 5? It's 2.5. And that's how much of the original concentrate is in tube 3, 2.5 milliliters. So it's 2.5 out of 10. Now, how do we change that? You take 10 divided by 2.5, and you get 4, and you put that over or underneath the 1. So that's a 1 to 4. So notice we've gone from 1/2 to 1/4. We've taken our dilution and cut it in half again. So if I do this again, I'm going to take my multiplier 0.5, and I'm going to multiply the amount of original serum in tube 3, 2.5 times 0.5, and I'm going to get 1.25. What's 10 divided by 1.25? It's 8. So we get 1/8. So by now you should be noticing what's going on. 1/2 to a quarter to 1/8. So what's the next one going to be? 1/16, correct. And then the last tube, 1/32. I don't even have to do the original math to figure that one out. What if we had tube 7? What would that be? If you're thinking 1/64, you are correct. It's 1/64. Ignore that line. I don't know why that happened. Okay. Something weird with my digital pen. All right. Now, what if it's not so easy? What if it's not twofold? What if it's some other weird number? Okay. Well, let's try this one. I've got 6 wells. Well 1 is 20 microliters of serum. That's my solute. And then wells 2 through 6 have 40 microliters of the diluent. Maybe it's water, I don't know. So it doesn't matter. All we care about right now is doing our math. Okay, so each of those originally contains 40. Now remember, I said reading is very important here. So I'm going to do my serial dilution by using 10 milliliter aliquots. So I'm going to transfer 10 each time, etc. Okay? So I'm going to set up my fractions just like I did before. And I'm going to put my total volume that's going to be in that well after the aliquots added on the bottom of the fraction. So 40 plus 10 each time is going to be 50. So fill that in. That's your total volume each time is 50. Now if you're getting a little scared or panicky right now, relax. Okay, I'm going to do another example after this one. You'll see the same steps again, except with completely different numbers. Okay, now how much of the original solution is in tube 2? Well, it's 10 because we just put 10 in. Now let's reduce that. Okay, so that's going to be a what? Oops, no, I don't want to end my show. That's going to be a 1 out of 5. And what is 1/5 as a decimal? If you're not sure, put it in your calculator. It's 0.2. Bring that up. That's going to be our multiplier. So I'm going to take 10 times 0.2. 10 times 0.2 is 2. Okay? I'm going to do that all the way across. 2 times 0.2 is 0.4. 0.4 times 0.2 is, are you doing this on your calculator with me? 0.08. 0.08 times 0.2 is 0.016. Now, we have to figure out these dilutions in correct form, which is a 1 to something ratio. So we have to reduce all of these fractions. So let's go back and do that. 2 out of 50 is going to be 1 out of 25. What about this 0.4 out of 50? What was the shortcut I taught you? Take 50, divide it by 0.4. What do you get? 1 over 125. 50 divided by 0.08, 625. 50 divided by 0.016, 3,125. So there you go. Very easy. Let's do another example. We're going to follow the exact same steps that we did before. Because like I said, this technique will work no matter what your dilution is, as long as you read the problem very carefully. Well 1 contains 20 microliters, so let's fill that in. Wells 2 through 6 are 90. 90, 90, 90, 90. Okay? A serial dilution is performed by moving 10 microliters from well to well beginning at well 1. What are the final dilutions in each well? All right, so we're going to move 10 across each time. Now, by now, you should be saying, okay, I get it. My total volume is going to be 90 plus 10, that's 100. Good. So let's go ahead and get our fractions set up. We know our final volumes in each well are going to be 100 microliters. Okay? Now what do? We take that original aliquot of 10, that's the numerator or the top number of our fraction for tube 2. So this is going to be a 10 out of 100, okay? 10 out of 100. That's easy to do in your head. I can reduce that. That is going to be 1/10, or a 1 to 10 dilution. As a decimal, 0.1, okay? So my multiplier is going to be 0.1. So 10 times 0.1 is 1 for tube 3. 1 times 0.1 is 0.1. 0.1 times 0.1 is 0.01. And 0.01 times 0.1 is 0.001. Okay, let's do our calculations here to get the final dilutions in each well. Okay, so this is simply a 1 to 100. Now, what about 0.1 over 100? 100 divided by 0.1 is 1,000, so that's 1 over 1,000. Notice each time we're adding a 0 on, 10 to 100, 100 to 1,000. Guess what? That's going to keep working for us. So this is 1 over 10,000. And then, of course, the final tube is going to be 1 over 100,000. The nice thing about these is once you see the pattern, you can continue it on through. Okay? So that's how you figure out serial dilutions. I hope that was helpful for everyone, and we'll end up with this little funny here. Hey dude, he just started diluting, but his cell phone will ring soon and he'll forget which tube he was diluting. And that happens, people. You start to daydream, you look at the clock, I don't know, but you come back to your tubes and you forget which one you were at, and then you got to start all over again, and then you it's crazy. So when you start doing these, just be careful about keeping track of where you're at, and it'll save you some time. All right, have a great day. We'll see you in class.